So let's have a look at visual representation. So histograms and polygons. So first of all, the histogram. So it's a visual summary and it's basically a column graph. And the columns represent the frequency of the scores. So things to keep in mind when constructing a histogram. You center the column on the score. Now those values, you sometimes hear them called the bins. Now there are no gaps between the columns, so they all join up. So here's an example of our pets one from yesterday. So there's the frequency histogram. Some people like to leave a gap on the left-hand side. You'll see mine's joined up neatly with the vertical axis. It doesn't really matter, but if you do leave a gap, make that gap half the width of your column. The cumulative frequency histogram, so there's our cumulative one, and you'll notice this time we are adding the frequencies each time, so the column gets bigger and bigger and bigger. All right, the polygon. Now the polygon is the line graph that we associate with statistics. So rules for constructing the polygon: we place the plotted points at the center of the top of each column. So again, here's our example for pets, and you'll notice I've plotted a point at the center of each column, at the top of each column. Now we start the polygon at the previous bin. Now my first bin is 0. If there was a -1, it would start, and actually, because I've joined mine up with the vertical axis, it'll actually start on the left-hand side of the vertical axis. So where the middle of the previous bin would be, and it'll finish where the middle of 5 would be. And then we just join that up with our line. So there's our polygon or line graph. The cumulative frequency polygon's a little bit different. We start the cumulative frequency polygon at the bottom left vertex, and then we join to the top right of each column, like so. So there's our cumulative frequency polygon. You'll notice I started there at 0, 0. So the first column is basically the diagonal of the column, but then we join up with the top right-hand side of each column. Sometimes you'll hear a cumulative frequency polygon called an ogive. Now, group data. How do we handle grouped data? So when you've got continuous or a number of different discrete pieces of data, and you've got lots and lots of pieces of data, sometimes we group the data into class intervals, also known as classes. So here's a guide to how you would group your data. Classes must be inclusive and not overlapping. So it would not be possible to put a piece of data into 2 different classes. They must only go into one. So yes, each score belongs to one and only one class. Any scores on the boundary must be treated the same for all classes. So for instance, if you always place it in the lower class or always place it in the upper class, then that's how you've got to do it for every class. And make a note how you've handled the data. Determine how many classes you want to make. As a general guideline, between 5 and 10 classes. Now, your intervals need to be the same width. And so you can work that out by simply going, well, the width of my class will be whatever the range is divided by however many intervals I've decided to use. Now, both your width and the number of intervals should be rounded up when you're doing this calculation. Now, for calculations, you assume each score will take the value of whatever the center of the class is for working out your mean, median, mode, etc. All right, here's an example. We've surveyed 300 students and we've found their heights. And we're going to place those heights into 8 classes. And we're going from 120 centimetres all the way up to 200 centimetres. And you can see how many fall into the different classes. So the first question, using a frequency distribution table, we're going to find the mean, the median class, so it won't actually be the median, but the median class, same with the modal class, our variance, and our standard deviation. So let's create our frequency distribution table, you'll notice I've added in not only frequency there, but also the fx, so frequency times score. The score, you'll notice for the first class, we're going from 120 to 130, so I'm assuming 125, that's the middle. Every score is going to have 125. Next one, every score is going to have 135, and so on, and so on. Let's work out the mean. Well, it'll be the sum of fx divided by the number of scores. Remember, we need to divide by n because last year, remember, we put probabilities in here. But here I'm using frequencies instead of probabilities. So I need to divide by n to get the same answer. And we end up with 156.5. Now let's put the fx squared column in. We need that to work out our variance. So s squared will be the sum of fx squared. So that's quite a large number for this example. Again, I've got to divide it by n, and I subtract the average or the mean squared, 262.75. To work out the deviation, we take the square roots of the variance, so 16.21. Now I'm creating a cumulative frequency. So same data, but I'm putting in a cumulative frequency column, or row, the way I've displayed my data. So you're just adding the frequencies as you go along. All right, let's summarize what we found. The mean is 156.5. The median class, that's why I've drawn the cumulative frequency here, because to work out the median, I need to know where the middle score would be. We got 300 scores, so middle, well, it's an even number. It'll be the average of the 150th score and the 151st score, and because I've got it in a cumulative, makes life a bit easier, but they both fall in the class of 150 to 160. The modal class also turns out to be 150 to 160. There is 100 people in that group. The variance we worked out to be 262.75 and the deviation 16.21. So how do we use the ogive to calculate the actual median itself? So not the median class. I need the cumulative frequency diagram so I can draw my ogive. So there we go. Now the median height will be 50% of the frequency. Now we know the overall frequency, there's 300. So therefore, at 150, I want to draw from 150 vertically, hit the ogive and go down. Now where does that hit the horizontal axis? That's the question that we want to know. It looks close to the middle, but we don't know for sure. So how can we calculate that? I've just drawn in that ogive and the sides of the column that it happens to be in. Now that column starts at 150 and finishes at 160. The height, at 150, we're up to a cumulative frequency of 99. At 160, we had a cumulative frequency of 199. So we can calculate out the median using similar figures. So I could draw a horizontal from 99, and I've got similar triangles and do it that way. Or I could just do something like this. So the median is, I know I'm going to start at 150, and how far across to 160 do I get? I need to know what proportion of that horizontal line do we have until we get to the red line. So the fraction will be 150 minus 99 divided by 100 times 10. How do I work that out? 150, that's our starting point. So we put that down. Now our fraction is going to be for our vertical heights. And we're saying we're going from 99 to 150 vertically. So 150 minus 99. On the bottom of the fraction, we're saying, well, how high did we go? All up. And all up, we've gone from 99 to 199. So that's 100. But then we multiply it by 10 because that's the width. And so that should work out our median for us. And we end up at 155.1. So it's very close to the middle, but not exactly the middle. All right, let's have a go at 15b.